Let us start with understanding learning. Machines learn just like humans. Both are clueless at first, make their own assumptions, and then improve. So, to understand this, let's imagine we are teaching a tiny, adorable 1-year-old to recognize an apple. Way number 1, the professor mode, or the old school method. You sit this toddler down in a quiet room, look them in their eyes, and start explaining. An apple is a famous fruit. It is mostly red. It has an oval shape, white pulp inside, and it's sweet. Apples are rich in nutrients and give you energy like Spider-Man. What about the toddler? Staring at you like you just spoke in ancient Greek. At this point, the poor baby is probably picturing some weird Spider-Man shaped fruit. Mission failed. See, the problem here is that you explained the apple, but the kid still has no idea what an apple actually looks like. It is like trying to learn how to swim from a YouTube tutorial without touching the water. They don't end well. So way number 2, the smart parent mode, or using some common sense. Instead of giving the baby a TED talk on apples, you simply show them an actual apple. The baby sees it's red, the baby feels its shape, and the baby sniffs that sweet apple smell. Over time, the baby watches you pointing at this weird red thing and calling it apple. And one day their tiny little brain goes, "So this is an apple." They start building their own little rule, also called a hypothesis in machine learning, about what makes an apple an apple. Baby's first hypothesis, apples are always red. Seems logical, right? But then, one day you hand the baby a green apple. Baby looks at it, raises an eyebrow and goes, "Wait, is this a capsicum?" And this is where the magic happens. You correct them. No, this is also an apple. Their brain updates the hypothesis. Apples can be red or green. Over time, after eating a bunch of apples and maybe even tossing some, baby refines their understanding. Eventually, they build a final model in their brain. Apples come in different colors but have a similar shape and taste. And that, my friend, is how kids learn. They start with a rough idea, test it, make mistakes, update their knowledge, and improve over time. This process has two phases. A hypothesis in machine learning is like the baby's first wild guess, wrong but well-intentioned. Second, a model is like the baby's final understanding, built after testing, refining, and lots of trial and error. So machines learn just like kids, but with less crying and fewer tantrums. Well, unless you are debugging at 2 a.m., then you might be the one crying. Alright, let's switch gears for a moment. We have talked about how kids learn. Let us see how you learnt cooking. How many of you like cooking? Or at least eating what others cook? Let us say you are not exactly a master chef yet, but you are passionate. You really want to bake the perfect cake. You read some recipe, watch a couple of YouTube tutorials, because everything seems easy when someone else does it. And now you are feeling confident. You gather your ingredients, flour, sugar, eggs, butter, and of course some love and passion. Now, as you are following the recipe, your inner scientist awakens and says, "Wait a minute, I can do better than this recipe." And this is where it all goes beautifully wrong. Adding more sugar will make this cake even better. Everyone loves sweet things, right? And what if I cook it on low flame? Slow and steady wins the race. And extra vanilla sauce, because who doesn't love saucy cakes? At this point, you are basically a mad scientist in the kitchen. And guess what? This wild experiment you just created, this is what we call a hypothesis in machine learning. A hypothesis is just your best guess about how things work. In this case, It's your brilliant idea that more sugar, low heat, and extra sauce will make the ultimate cake. Now comes the model phase, when reality hits you like a soggy cake. Now comes the moment of truth. You actually bake the cake. You follow your sweet hypothesis. Extra sugar, low heat, extra vanilla sauce, drown that cake. And now the final step, taste test. And what do you get? A sugar-coated disaster. It is sticky, uncooked, syrupy, crime against humanity. You just invented the first inedible cake in history. You take a bite, immediately regret life decisions, and now you are questioning everything. Was this a cake or revenge from the baking gods? And guess what? This horrendous cake is your first machine learning model. It is the result of applying your hypothesis, testing it, and realizing you messed up. Now comes the iteration phase, the comeback story. Now, like a true data scientist or a baker who refuses to give up, you go back and analyze what went wrong. Okay, too much sugar, let's tone it down. Vanilla sauce, let's not drown the cake in it. Low heat, that was dumb. Let's cook it at a normal temperature. Armed with new knowledge, you try again. New hypothesis, new experiment, new cake. And this time it's better. May not be perfect, but definitely not a crime against humanity. You tweak, test, improve again and again. Until finally, after multiple failures, sugar disasters, and questioning your life's choices, you bake the perfect cake. And that, my friends, is exactly what happens in machine learning. So the takeaway, a hypothesis is your wild guess about how things work. A model is what you get when you test your hypothesis in real life, which might be a disaster at first. Machine learning is the same as baking. It's all about trial and error, learning from mistakes, and tweaking until you get it right. Now let's see how machines do all this magic. Let's leave the kitchen for now. I know, saying goodbye to cake is painful, but trust me, where we are going next is just as exciting. We are hitting the road. Imagine we are in some city. Pick any city you like. Let us just hope the traffic isn't as bad as reality. Now we want to predict the taxi fare for any distance traveled. In a perfect world, this would be super easy. Base fare 20 units, because taxis don't start for free, obviously. Cost per kilometer, say 15 units. So if you want to go 2 km, the fare is base price 20 plus 2 times 15 is equal to 50 units. Easy math. What could possibly go wrong? Everything. Welcome to the chaos of real life. In reality, taxi fares don't care about your clean equations. Instead, you get traffic signals that last forever, drivers who drive at the speed of a confused turtle. So what happens? The perfect formula goes flying out of the window. Instead of just assuming the cost per kilometer, we do it the machine learning way. We gather real data and let the model figure out the best price formula based on the actual taxi fares. Let's say we collected real taxi data because standing at a traffic signal gave us nothing better to do. We have distance and fare in the data. Plot these points on a graph. Yes, I know graphs sound scary, but trust me, they are just adult doodles. X-axis distance in kilometers and y-axis fare. Units of disappointment when you see the bill. And guess what? The points kind of follow a straight line. Well, almost. There are some random fluctuations because, again, traffic chaos. So our first wild guess, that is hypothesis, is the fare follows a straight line. That's our starting point. But let's be honest. We don't just randomly draw a line and hope it works. That is what we do in kindergarten, not machine learning. Now finding the best model. We need to find the best possible line that actually fits the data. So let's say we take a random guess for the base price and per kilometer rate and wait to see how it works. Your first guess model was way off, predicting too high, like when your cab charges you a congestion fee for no reason. But that's okay, it's just our first random try. Even machine learning model starts as a mess, just like every first pancake you make. Now instead of crying over our failure, we do what real data scientists do. Tweak the model based on what went wrong. Move the line down a bit. Let's try it. Tilt it slightly clockwise. Try again? Yes. So we adjust the model and run it again. The new line is better, but wait, it's still not perfect. New prediction was too low, which could be amazing, but sadly, taxes don't do discounts. Another tweak, another attempt, another disappointment. But we keep going, because machine learning is nothing but educated trial and error. And because giving up means walking instead of taking a taxi. Finally, after several rounds of tweaks, corrections, and emotional roller coaster, we find the best possible line that fits the data. Eureka moment. Now we can predict the taxi fare for any distance. Want to travel 2 km or want to go 20 km? No problem. Model will calculate it for you. Machine learning is not magic. It is just math that doesn't give up. Humans learn the same way. We try, we fail, we cry a little, we try again, and eventually we get it right. So the learning starts with a rough guess, hypothesis, which is usually wrong, just like my first pancake. We adjust based on data and keep improving, or in simple words, mess up, fix it, repeat. After enough tweaks, we get the best model. Now you might be thinking, okay, but how do we actually find the best model mathematically? We are getting there. In the next session, I promise I will make it as painless as possible. Until then, keep learning.